Hi, this is our demo 4. So in this demo, we implemented the bully algorithm. The goal of this leader election is for it to appoint a leader among the three API servers. So using this bully algorithm, what we have is in our index.ts, we have um, a WebSocket server, which will talk to all three API servers. The WebSocket server will take three messages, election, leader, and health message. Um, and then it will use a cron job, which will trigger every minute. And this will just be used on a cold start. So in our leader election, in this manage database cluster function, what it will check is it'll try to get the leader. So it will connect to a Redis instance, which will store the leader. Um, and here it'll check if the current port is a leader. And if the current leader port is null, or if the current port is greater than the leader port, it'll initiate an election, and it's not running in the election. Or if it's not the leader, it will try to do a failure check. So what it will do is it will just on all nodes that are higher than itself, it will just do a health check. And if it times out using the timeout method, the API server has leader server has failed, so it will just initiate an election. In the initiate election, what it will do is it will send an election message to all ports greater than itself. And if it doesn't receive anything and it's still running in the election, it will declare leadership. Or if the node higher than itself is alive, the node higher will send a bullied message to, and the current node will receive that and it'll drop out of the race. And then if the server doesn't hear back from anyone and it's still running in the election, it will declare a leadership. So it will set itself to true, and it'll set the Redis instance layer key to its current port, and it'll notify all other servers. Just so send a leader message with a port number. And yeah, that's about it for the leader election. So basically, what our leader will do is it'll check the health of the databases, the primary and replica, and it'll sync the databases together. So if it is the leader, it will check the primary and replica database. All that does is you'll just connect to the database client and replica client, and just try to do a select query. And if it works, it's alive. If it doesn't, it's not. If they're alive, then what it will do is it will try to acquire a lock for synchronization with a time to live of 5 seconds. And it will use acquire lock, which basically acquires the lock from the Redis instance. If it can't acquire the lock, it'll just return. But if it does, it will try to sync the database, which we haven't done for this demo, but we'll do it for the next one. Um, and then once it's synced the databases, it'll release the lock. So I'm just gonna Docker compose up and show you the leader election. So the Docker containers have all built. As you can see, all the servers are running. So on cold start, it's going to run the function. So as you can see, it says current leader is null. That's because the Redis is empty. So because of that, it's going to initiate an election. And all three servers will initiate election on cold start. So as you can see, port 4000 is going to send an election message to the one higher than itself. So 4001, 4002. These servers are going to receive that message and they're going to send a bullied message back to them. So port 4000 got bullied by 4002, and then port 4000 is just going to initiate the election. And then that also got bullied by 4002. And then in the end, 4002 doesn't really receive anything. So what it says is that 4002 is the new leader. Um, and then it sends it all to the other ports, 4001 and 4000. And that acknowledges that they're the leader. And as you can see, current leader is 4002. And then for the current leader, we'll check the health of the databases. So primary is alive and replica is alive. And then it'll try to acquire the database sync lock. So it tries to get it, it gets the lock, and then it just console logs that it's syncing, but we're implementing it for next demo, and then it releases the key. And then as you can see, the other servers that are not the ports, which are not the leaders, which will do a health check. And as you can see, you'll just do health and they'll see that port 4002 is alive. So they'll do nothing. And now I'm just going to crash one of the leader server, and so that reinitiates the election. So I'm just going to go to my Docker file. Just go to containers, and then API 3 Is there a leader? So I'm just gonna pause it, go back here. So you can see API 3 has exited with code 1. So just give it a second and it'll run. So it's been a minute, so the cron job runs. Only API 1 and API 2 are gonna run it. You see that the current leader is 4002, so they do a health check. It fails, so they start an election, and the whole leader election runs again. This error message is just because it can't connect to the API server. And then 4001 is the new leader. Yeah, and that's our demo. Thank you.
Hello everyone. I will be continuing our demo for our fault tolerance. In the previous week's demo, we did not replicate the proxy server. So now we have replicated it. We have two. We have the primary and the backup. And this is our fault tolerance mechanisms, one of them. So if the client sends a request through the main proxy and the main proxy is down, it will use the backup proxy to forward the request to our replicated API servers. Um, Before I dive into the demo, I'll go over the code real quick. So first, we're using Nginx for our load balancing and the reverse proxy. What we had to add was a health endpoint to actually get the health of the proxy server. So if the server is alive and it's up and running, then it will return a simple 200. Next, we had to update our API resource definitions, and we had to add these headers to prevent CORS conflicts. And we had to do the same for the WebSocket resource as well. If I open our Docker Compose here, we can see two new service definitions. So we have the main proxy, and this runs on port 3000, and we have the backup proxy, which runs on port 3001. Additionally, we have a fetch with proxy wrapper function to wrap all of our API calls. So this will actually get the primary proxy and the backup proxy URLs from the environment file, and it will do a health check on the primary proxy first. So it hits the health endpoint, and if the health is okay, it uses that for the fetch request. And if it's not okay, then it goes to use the backup. So it pings the backup health, and if the backup health is okay, it will use the backup proxy for fulfilling the request. So let's go into the demo now. I can go ahead and if I log in to an account, uh, if I clear these logs, we can see that it used the primary proxy for the request. And this is the URL. It's on localhost port 3000, like I mentioned. I'll clear this, and if I go to the community page, it's still using the primary proxy and for all of the other pages as well. Now we'll go ahead and we can create a new sighting. So here we go. We can capture that image, scan the goose bird, and we can hit submit. It's using the primary proxy for this request as well. So the sighting was added successfully. Now if I go to the community page, here we can see the sighting that we added. I'll purposely kill the main proxy that we have. So I'll stop that container. And now what I'll do is I'll go back to the home page and we can see that it used the backup proxy for that request. I'll go back to the community page and it's still using the backup proxy. I can like this and it's still using the backup proxy for all of this. So that is another one of our fault tolerance mechanisms.